This is the ESP32. Today what we're going to do is we're going to throw the new firmware that is available on the website onto this, and we're going to turn this into an EZB so that you can connect servos to it, and you can connect like LEDs or sensors, whatever you want. And it is an Arduino-based firmware, so it's going to be easy to program with your Arduino IDE, and that's it. So let's have some fun with that. Let's first start by programming the firmware onto this machine, onto this device. And then what we'll do is start hooking up servos to it, and I'll show you what the wiring is going to be like and what you're going to be up against. So click on getting started.
Use one of the transistors to control the...
And we're robot builders.
Because we don't want to use that.
So I'm using Easy Builder Designer Beta. You got to find the controller here in the list of all the microcontrollers. This is it here. So the one I'm using, if you guys actually want the same form factor and the same pinouts, it is actually called the DOIT ESP32 DevKit V1. Okay, so we're going to click on this controller, and you can read a little bit about it, and it gives you instructions on how to get this thing up and running. Now, we, however, are going to walk through this so you don't have to follow the instructions. You can follow me. So here's the firmwares that are supporting this. Looks like, so I have a version 2 of this firmware. We click on more info. We can read about the firmware revisions. Let's back out of here, and let's just click download version 2. All right, now we're going to extract that in our downloads folder. And here it is. So I already have a folder on my documents called Arduino, so I'm going to throw that in there. There it is. Okay, so we're going to double click on this file. Okay, so back to the instructions from here, firmware instructions. So in order to get the libraries that you can use to compile this, you have to copy this link and you have to paste it into File Preferences, into this Additional Boards Manager here. Okay, now I've already, as you can see, I've already added this. So paste that URL in and click OK. And click OK. And then go to Tools and it's under Board right here. And then choose Boards Manager. And this is going to show you all the different boards that Arduino will compile with. And you want to type in ESP32, and there it is. And then you want to click the install button. So I already installed it, but you would have an install button. Click it, wait, it does take some time. Depends on the speed of your processor and your network connection, but it's it could be a couple minutes, up to 10 minutes to download and install. Let's see, let's get this here. Okay, so we have the ESP32 plugged in to the into my hub here. And the hub, of course, is connected to the computer. And we can now see under Tools, our COM port. So if you have multiple COM ports, you can just have to find out which one is for this. And then under Board, you're going to want to go down to the small arrow at the bottom and scroll down until you find DOIT ESP32 DevKit V1. Now, if you look at this list, these are all ESP versions. So when I talked about how many ESP32s there are, this is all of them, right? So there's a ton of hardware here that ESP32 is based on ESP32. So you want to select that one. And then what I'm going to do just to demonstrate how it's working is we're going to open up a serial monitor. And the serial monitor is going to show us debug information. And you want to set the debug information to 115200. And then back in the code, we have a couple different options here to configure. The first one here, which is our AP mode or client mode. So this determines how we're going to be connecting to the network. If we're going to connect to an existing network, we would comment this out, and then you'd edit this stuff here. So if this would allow your device to connect to your home network. So in here I would put my network and I'd put in my password and then it would connect. Now you're not going to know what the IP address is, so there's two different ways to do it. One, you can look inside of the serial monitor in here. It's going to show you the IP address. And the other way is to look at your router and see what devices have connected. There is a third way where I guess you can scan in Easy Builder for the device, but that takes a while and it's kind of inconvenient. What we're going to do today is we're just going to use the default AP mode. So I'm going to have it like this. and we're going to connect to it directly through Wi-Fi. Now, because I already have an Ethernet connectivity on my laptop connected to the network, I'm not going to lose network connectivity to connect to Wi-Fi because I already have the internet connected through Ethernet. And because this is blank for the password, it's not going to prompt me. It's going to be an open hotspot, as you're going to see in a second. Now, the rest of the data down here, these configuration values, there's no point for you to have to configure them unless you're going to be modifying the code on how this actually works. So before we program it, let me go over some of the code because I know you guys are probably interested in the firmware and how it works. So this is so Arduino provides a Wi-Fi server and Wi-Fi client. There's an HTTP, there's a bunch of different libraries they provide. So we're going to be using the Wi-Fi server, which is the actual Wi-Fi network. So that's what does the client or AP mode. And then we have the Wi-Fi client, which actually is the TCP server that the computer will connect to. And then this stuff is for your buffers, and then this is for simulating serial ports for baud rates. And you can see here this big list of stuff. I'm going to plug in my mouse. There we go. And this big list of stuff here, this is all the commands that the EZB protocol uses. And of course, as in other videos, if you want to take a look at the Arduino video where I added a wheel counting capability, you'll see how I can actually add new commands to this so that it can be used inside of a new plugin. This setup here, this is your serial port that's used for diagnosing information, which we're going to see in this here. And then you can see there's an if condition here for if it's AP mode or if it's in client mode. So you can see how it connects to the network and it prints out some data and it specifies the IP address and things like that. And this is kind of neat. It's an event which will execute whenever the Wi-Fi system changes. So you can actually say, hey, I want to see when the Wi-Fi interface is ready, things like that. So this will pop up inside of the serial monitor. And if we keep going down, we have our main loop, which runs. And our main loop, what it does is it just checks and says, is there a new client? So is Easy Builder trying to connect? And it'll reset the buffers to make sure that everything's reset back to 0, just in case there's anything in there. And we'll take that connection, tell the user to the terminal, and then we'll loop forever while a client is connected. So this is where the actual protocol gets executed from, in the Easy Robot protocol. And all this stuff here is my pretend DMA buffer. It just takes in all the data and throws it into an array in a buffer array for you to be able to read from. And then I have a whole bunch of stuff here for connecting to different ports. And this one is interesting. There's different translate functions here. It's because the ports on the ESP32, we can get a close-up here for you to see. I don't know if you can. It's kind of shiny, and there we go. But the numbers that are on here, that on the labels, you'll notice, are actually ports. They're called like, this is like D34, D35, D25. Like they're just broken out numbers all over the place. And in Easy Builder, we like to have everything like D0, D1, D2, etc. So this translates those numbers that the Arduino specifies, like on the ESP32, into values that Easy Builder will use. And this is the main protocol here. So this is how it actually works with all the different commands. So you can dive into this if you want to see how, for example, reading digital ports and turning off digital ports works. So since we don't have to change anything down here, because this is the code overview, we'll go to the top and we're just going to hit our button here to upload and program the chip. Now I'm going to load this up in COM3. Okay. Now watching this window down here, because you might see a message that says writing. I'm not even sure what it says. We're going to see in a second. But anyway, if it can't find the board, there's a button on here that you actually have to push. So we might have to push this button here on the right if it doesn't work. So we have to wait for it to finish compiling, and then you're going to see if it works or not. I think what this button does is puts it into a firmware mode. And sometimes, there we go. See, it says connecting and it says writing. Okay, we didn't have to push the button this time. I have another device where when I write to it, I actually have to push that button every time. So it's programmed, and as you can see here, we have an SSID called "Get Off My Lawn," and there's no password. And you can see here some events that the interface has come up, and the IP address of the device, because it's an AP mode, and it's waiting for an Easy Builder client. So if we look at our Wi-Fi network, and scroll through, there it is. Get off my lawn. So we'll connect to that. And I don't know if it shows you anything here. Let me see. It does. It just told me that and it signed an IP address to a client. So you can see that we've actually connected to this device. You can see some log information. So now that we have this up and running, we can load Easy Builder and connect to it. So let's load up Easy Builder. And what we're going to do is we're going to connect to the network. So we'll push connect. And there we go. So you can see that it's connected. Let's take a look at the debug information. Okay. What I'm going to do is I'm going to load up the debug window here, so you can see the information that was sent over when it connected. So we'll make this window a little bit bigger so you can see everything. Okay. And it's probably hard for you to read, so let's push the copy button. And let's paste this in Notepad so you can read it. There we go. That's big. Look at that. Cool. Okay, so you can see here that we've connected to the device, and it reports the capability controller. And the firmware that it's using that we know is this. And here's the capabilities it supports. So this firmware that I've released does an ADC with 12-bit resolution. It can read and write all digital ports. It has a hardware UART, PDA and servos, and it's got native Wi-Fi capability. So those are the things it can do. So it can't do audio, it can't do video, but you can control servos. So that's cool.
Hello, Babu.
So I'll close this down. And let's start by demonstrating maybe the ADC. So let's just add an ADC graph. And we'll configure this for a fast speed. And we'll click Save. Now there's an ADC port on here. To find out what ports are available, let's visit the website again and scroll down until we get the ports. So we're using this 30-pin version here. And you can see that on the top left are our ADCs. And then you have your D0s, D1s. And then beside it, we put in gray what the actual ink silk screen of the chip is going to read. So you can match up D4. If you look on the board, that's actually called GPIO 12. And then it goes 0 to 5, and then D6, D7. These two are not hooked up because these are actually the USB connections, so you can't use these as ports. And then it continues on, and then you have 2 ports here. This is your UART. So in Easy Builder, if you're using UART 0, that's going to be these 2 here. And then you have 2 extra ports down here. So we can put our finger up around this area where the ADC ports are. Right down here, and we should start being able to actually see ADC from our finger. There we go. So we're seeing the ADC voltage being read, which is nice. Close this down. And now let's add the benchmark utility. This allows us just to see how fast the actual connection is between the Easy Builder and this device over Wi-Fi. So I'm going to change this from 30 to 300. Gives us a good idea. So let's click Read 300 ADC values. We'll click on this. It's running. There we go. So we're at 167 commands per second. I think that's great. Let's try it again. Look at that. It's wonderful. Now let's try reading some digital ports. So we're going to click on this one over here, read 300 digital ports. Probably a little quicker than ADC. Yeah, 196. ADC does have a sample time, so it does take a little bit longer than reading digital. Digital is on-off, or ADC is like a voltage range. And then we can, for example, push and say set 300 servo random positions and see how fast that is. So we sent 3,946 commands per second, and let's click read. And I think what happened is by clicking and sending all that data is it might have disconnected the connection. So the TCP stack on this device can't take commands too quickly, but it can definitely take them at a decent rate. So what I just demonstrated here by clicking on that is that this device couldn't keep up. So what we'll do just to cycle the power again, plug it back in.
We're going to do a little transistor circuit right on top of here.
I'm going to reconnect over a network, and I'll push the connect button. I just have to make sure that my Wi-Fi is connected to it. You guys can't see this part.
And we'll have to do the same for the LED.
Because it's behind my window, behind my face. All right, so we're reconnected.
Oh, yeah.
So let's start again by checking out the digital ports. So let's go to digital and click read digital. And here we can specify the port that we're going to read. So let's read something down here in the bottom right. So let's set this to say, I don't know, D8. And that's what it looks like. It's already set for D8. So I should be able to put my finger again around this area on the board. And I should be able to see the screen showing me that it's reading the values. Let's see here if I can make it work. There we go. You see it sometimes turning green. So we're actually reading the digital values right now. It's cool. Okay, now let's try controlling a servo. So this is where things get a little bit crazy because you can't just plug a servo directly into it. So I have a servo here. And
You can connect these up to
what we'll have to do is,
major motors now if you want.
now that you can see the servo actually has
Major motor wires a little bit.
an extra wire coming out of it, because in a previous video, I don't know if you recall, we actually hooked up this wire to the potentiometer so we can read the position. So you can actually move the servo and do what's called reverse kinetics. So you can't just take this and plug it in. It just doesn't work. You can't tie it around it either. It doesn't seem to work. You can't put it close to it. That doesn't work. You actually have to like wire it up. So let's do that. Of course, I have my trusty drawer. Lots of things in here. Let's see. What are we going to need?
Let's tin those wires. Stuff out of here. So many things.
Maybe I'll use this. This breadboard will be easy. All right, we're gonna breadboard today. This is serious hacking now. Breadboard. All right, so we'll throw this guy, unplug these. I don't know what's going on here on the breadboard. There we go. Let's see. So I have an LED here. Let's hook up the LED from ground to pin D5 on here. And then let's go back to our software and let's add a digital, and let's configure this to be D5. We should be able to turn that LED on and off.
Controlled.
Oh, it's not D5. Silly. Let's check the list here and see what D5 is. So D5 is D11. So let's go back to our software and configure this to be D11. And now we should be able to turn it on and off. It is working. Cool, so we have like a little Wi-Fi $4 EZB. It's great. Let's close this down and let's start on our servo. So I'm gonna have to give this board some power. I'm gonna use my adjustable power supply here. And I have it set for 7.4 volts. That's good. That's generally what the lithium polymer batteries are gonna give you. And that's what Easy Robot servo is like, and that's what we're going to be using. If you're using other brand servos, you might want to just keep an eye on the voltage and make sure you're not giving it too much. A lot of servos just like 5 volts. So we'll plug this in later just to make sure that we don't get any white smoke. So what I have here wired up is I have this barrel jack, connected to this runner here, which is our power runner. And so I have an LED here to demonstrate that there's power going to it. I have a resistor going across for that LED. And I have a ground, which is brown. So we're going to want to share the ground between this board and the power source of the servo. So we're going to hook this into the ground pin of the ESP. Hopefully it's not too blurry for you.
Servo Control pager motors, geared pager motors, I should add. It's out of the way.
So there's a ground pin next to the V-in pin here, so we're going to connect to that.
So, there's a few other things we have to wire up.
So I have to move this over a notch. I'm going to firm.
For the power, this is the power lead here, and then we'll go to the easy.
So plug this into ground. So it's pin number 2 in the bottom down here. And we don't have to give it power because we're going to give power to the servo. So let's just use this wire and plug it into the servo directly. So remember, on the servo, this is ground, voltage, signal. So we'll plug this into power, which is the middle pin. And now we have another ground pin here. And this other ground pin is coming from the ground from the power supply, so we'll plug that into ground of our servo. And now we need a signal from one of these pins to here. So we have another jumper jack here. We'll take this jumper and we're going to go, we'll just hook up this D23 here. We'll plug that into the signal pin. And now we should be able to give this power and nothing should blow up. Cool. So my light came on and there's power. And we're not giving power to this. This is still powered off USB, so it's a separate power source. All we're doing is sharing the ground between the two. That just allows us to be able to power the servo off of the voltage coming directly out of the power supply through this barrel jack. So back in our software, we can add a servo control. This is a horizontal servo control. And now we did plug this into D23 on the controller. So let's look at our schematic here. D23 is D6 in Easy Builder. So we'll go Easy Builder, click on this, and we'll choose D6. My brain didn't work. We'll choose D6 and click Close. And now let's set our limits. And you can hear the servo moving. You can see it moving here as I do this. So now we can move the servo. So this is wonderful. It's a $4 controller, Wi-Fi enabled. You can throw these around your house. Control blinds like I'm going to do. This is awesome. So I told you this is going to be real quick, but short hack, and it pretty much is. And then there's not really much more we can do with this thing. You know, all the regular commands in Easy Builder are still going to work. So we can add, let's say, speech recognition, we'll say. And we'll edit this. We'll add a command called move left.
Actually, let's keep, so it's EDC. We want our emitter.
And we'll just have our servo
negative lead. So
on D6. Move to position 180. And now we should be able to say, move left. Move left. You can see my confidence was too low on this. Let's edit this and decrease the confidence a little bit. We'll bring it down to something like 60. It all depends on your type of microphone you're using. Move left. There we go.
Trim the resistor.
And I don't know. I don't know what else there is to do with this thing. That's about it. We can read values, we can set values, we can move servos.